Hey folks, welcome back to another video. Today we're looking at question 128, longest consecutive sequence. The way we'll be approaching this problem is by using a tree set. So let's get started. Before we actually initialize the data structure that we need, let's cover the base cases. So if the length of numbers is equal to 0, as in there are no elements, there are no consecutive elements as well, so we just return 0 as is. So if nums of length, actually I think if nums of length is equal to 0 or nums of length is equal to 1, let's just return nums of length because those are the answers. So basically what does that mean? It means that, hey, if the number of length, the length of the array that's given to us is equal to 0, there are no elements, so the longest consecutive sequence is 0, so you return 0. In case when it's 1, since there's only 1, you just return 1. So those are the base cases. So let's go ahead and initialize the tree set. So tree set integer set equals new tree set. And then you add all the numbers from the nums array to the set. So the set.add num. And after that, it's pretty simple. So you need to take the count. The count would be, let's say, how many times have we actually seen the maximum number, right? Like the maximum number of consecutive sequence. So even if there's one number, right, we care about that. So let's initialize that as 1. We have max to be equal to 1 as well. And you need to have int current number that you're looking at. So the current number, so we need to start at the lowest element. So that would be set dot first. So basically we're looking at the very first element, right? And then we have a while loop. While the current element is not equal to set dot last, we need to keep iterating, as like we want to go through all of the numbers that are given to us in the set. Actually, let's assign that to an integer because calculating set.last takes some amount of time, which we could avoid. All right. So while the current element is not last, we need to keep iterating. So let's say int next would be equal to current element plus 1, right? So if a set contains next element that we're looking for, we need to initialize the count by 1. We need to in say current is equal to next, right? We need to update the current element that we're looking at, and then we need to say, hey, we have incremented the count. If it is higher than the maximum that you've seen previously, update that. Awesome. And in cases where the element doesn't exist, you reset the count back to 1, and then current is the next higher element that we see. So it'll be set.ceiling next. So basically, ceiling, what it does, it gives you the next element, the next highest element, which is in the set, which is greater than next. So basically, the next element doesn't exist, right? So that's the reason why we enter the else side of the loop, and it'll take us to the next number that we see, and it resets the count. So I think that is all of it, and in the end, you just return the max. Yeah, so let's try compiling this. Okay, so the first few test cases are okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity. The time complexity is n log n actually, because inserting all of the elements within the set, so insertion of an element in the set is log n time, and then since we're inserting n elements, it'll be n log n, and the space complexity is O of n since we are using a tree set. Awesome. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I definitely appreciate that. It keeps me motivated to make more videos. Thanks so much, and I'll see you folks soon. Peace.